For particle motion, they're going to give you an s of t. But the good news is velocity and acceleration work the same way. Velocity is still ds dt. Acceleration is still dv dt. So everything we do today is going to be kind of like vertical motion, but it can be harder because the equation given can be more complicated than just this. All right, so let's do an example. The position of a particle that is moving in a straight line, and we almost always think of these as horizontal motion, so they're just going like back and forth rather than up and down. And we don't know why it moves this way. Like someone was asking, like in physics, you do a force diagram and figure out the net x force and all F equals ma. Like this is sort of a few steps after that. Like I don't know what the forces are, but this is the motion that's happening. So this is a little bit downstream from whatever's making that happen. T is in seconds, S is in meters. Find the velocity. Well, this is the same type stuff. Velocity is ds dt. The derivative of the position. So the position equation is a little more complicated than it was Friday, but it's the same process. Take the derivative of position to get velocity. Velocity after 2 seconds. Okay, so let's plug in 2. Three times 4 minus 24 plus 9. Negative 3. Yeah, meters per second. After 4 seconds. Same thing, plug in 4. I mean, not same answer, but same process. 3 times 4 squared minus 12 times 4 plus 9. Use the calculator. 9 meters per second. There are a few new things coming, but right now this is just the same stuff we did, like velocity is derivative of position.
So that's just 48 minus 48, and then it's just left with 9. That's what I'm assuming.
More stuff from physics. Particle at rest.
Somewhere.
What does that mean?
Oh, it equals 0.
It means velocity is 0. So we'll take our velocity equation and set it equal to 0. Now we can figure out, well, I hope it factors. I guess I don't know that it factors yet. Let's take out a 3, make life a little easier. If it doesn't factor, we'd have to use the quadratic formula.
But it does.
But it does, so that's good news.
Negative 1 times negative 3.
So t equals 3 and t equals 1. And again, always checking to make sure we answer the right question here. When? So what time is the particle at rest? Well, 1 and 3. When is the particle moving forward? That is in the positive direction. So what's it asking for here?
When is the velocity positive?
When is velocity positive? Well, I know when it's 0, so I'm going to do the number line thing with intervals and check the intervals and then figure out where velocity is positive. And since I know that I mean, I can.
You have all 4. And you have 1 and 3.
1 and 3.
And you.
So
have
I'm just
2
checking the
And
intervals.
you have 2 volunteers already.
I do have 2 volunteers already.
And
AP
0.
test does this a lot. Like, you're working along and then you realize, wait a minute, they've actually helped me out here. If I pick 2 and 4 as my volunteers from those intervals,
2 is negative.
then I need to find V. Well, V of 0, but that's easy. If I plug in 0, I get 9. So 0 to 1, we're positive. If I plug in 2, I already did that. Negative 3. So velocity is negative between 1 and 3. If I plug in 4, I already did that. I get positive 9.
So then it would be from 0 to 1 and then 3 to infinity?
0 to 1, 3 to infinity. Why did I stop, or why did you start at 0?
Because there's a straight line right there. There's not narrow.
Okay, well, why did I put a straight line there? There's the better question then. Yeah, you can't have a negative time, at least for our purposes.
And what's BC? But a better question is, so for from 0 to 1, would you have a parenthesis next to the 0, or would it be a bracket?
Really good question. I don't think they would take off for either one, because you could argue it either way. You don't really know what's happening to the left of 0, so it's hard to say that you're increasing because you don't know what happened to the left. So parentheses are safer, but I don't think they would take off for that. Draw a diagram to represent the motion of the particle. Okay, this is what's new. I haven't done one of these before. A motion diagram. And I say we haven't done it before. We've kind of done it when we've tossed something off a cliff and we drew like a little parabola of it going up and then coming back down. But now this is the left and right thing. So I want to picture a picture of what the thing's doing, or what the particle's doing. So I'm going to put it on a distance. Let's call it a position number line. So I'm going to lay out a number line of position, not of time, but of position. So I can kind of get a picture of of what's going on. And what I want to plot is S of 0, because that's where it starts. Now, it doesn't always start at 0. In fact, I'm going to make a little table here for my number line. What's its position at 0?
Positive.
What's its position at time equals 0?
0.
0. Look back at the equation for position. Plug in t equals 0, you get 0. So it doesn't always start at 0, but this one starts at 0. And then you also want the position when velocity is 0, because that's where it might be changing directions.
So increasing, decreasing value.
So kind of an increasing, decreasing thing. 1 and 3 are critical points of S. So we're used to making a table with critical points on it. Just kind of using it in a different way, but it's that same process. Here's my critical points. Do I have S of 1 somewhere? I don't think I do.
I have
Plug in 1.
minus 6 plus 9.
So that one's not too bad. 4. I'll put these on the graph in a moment. And then if I plug in 3, 27 minus 54 plus 27. Oh. Well, that looked terrible, but turned out to be just fine. So now I want to kind of sketch out what this particle is doing. It started at 0, a position of 0, and time equals 0. 1 second later, it was over here at s equals 4. So we're trying to like get a visual of what's happening. It moved to the right for a second until it got to s equals 4. And then it turned around because its velocity was negative between 1 and 3. S of 3 was back at 0. So when time equals 3, we were back at 0. Back at position equals 0. Which way does it go after that?
Back to the right.
And how do you know back to the right?
Because the velocity between 3 and 4 is positive.
Yeah, you can go negative. So you could go negative position here. But we just said a minute ago, after time equals 3, the velocity is positive. So we're headed out that way. So now we have a picture of what this thing is doing. It moves to the right for 1 second or 4 meters. It moves to the left to time equals 3 and back to 0. Then it moves to the right after that. That's a motion diagram. That's probably the most missed part of the test, is drawing a motion diagram. If you can draw the motion diagram, you can get the rest of the questions right. Find the displacement. F and G, remember displacement versus total distance. That's another physics idea.
Displacement is when t is at 5. Just strictly just the equation.
Well, minus where you started, so be careful.
Oh, displacement.
Because not your position at 5, but your displacement from 0 to 5. So where you're at minus where you started.
So if s of 0 is 0.
But it turns out that way for this one. But s of 5 is 5 cubed minus 6 times 25 plus 45 is 20. So could put that out here on this graph somewhere. If it helps us visualize what's going on, at t equals 5, we're 20 meters away from where we started. We're at position 20, which is 20 meters away from where we started, since we started at 0. Total distance. For total distance, I'm going to need to be a little more careful here. I think I'll just use my picture to figure out. Well, from time 0 to 1, we traveled 4 meters. See how many colors I can use here. From 1 to 3, we traveled. Well, we did back up 4, but how far did we travel? Just distance. 4. Right? If you run 100 meters down the track and then you run 100 meters back down the track, how many meters did you run?
200.
According to
200.
none.
But your total displacement would be 0. And then from 3 to 5, since we were stopping at 5 seconds, how far did we run, or how far did our particle travel? 3 to 5, that was 20. So our total distance traveled
28.
is 28 meters. But there's not really a formula for that. That's a draw a correct motion diagram and piece it together. Alright, so that kind of stuff was a little bit new. Acceleration, that's old news, because how do we find acceleration? dv dt. So go grab velocity wherever it was, way back up the page. Take its derivative and get 6t minus 12. That would be the acceleration at time t. The acceleration at time 4 would be, well, safe stop, 24 minus 12. For I, let's just say no, that's not helpful. We're going to pass on that. We will use that space, though, so don't go crazy and block it all out. When is the particle speeding up versus slowing down? This gets a little bit tricky. Speeding up.
Cavity.
It's not about concavity, because concavity would be second derivative, that would be acceleration. Let's see, speeding up. The easiest way to think, or the easiest case would be if velocity is positive and acceleration is positive. You're moving forward, you press the gas pedal, you're accelerating, you're speeding up.
So if the
That's-
first derivative is positive,
Hold on.
and the second derivative is
Slowing down, let's say your velocity is positive, so you're moving forward.
But you got a stop sign coming.
You got a stop sign coming up. So you press the brake, you slow down. Slow down. What's your acceleration?
Negative.
less than 0.
Your velocity is trending down, so your acceleration is negative. Yes. Those two cases make perfect sense for most people. You're driving forward, you press the accelerator, you speed up. You're driving forward, you press the brake, you slow down. Got it. The trick to these is if your velocity is negative, so you're backing the car out of the driveway, you're going negative. You hit the gas pedal. It makes you go faster, right?
You go negative faster.
You go negative faster. That's right. So what is your acceleration if you press the gas pedal and you're in reverse?
Negative.
Your velocity is getting more and more negative, so your acceleration is negative.
Was it only negative to what's relative to? Or?
If your velocity is decreasing, that's a weird way to say it, but if your velocity goes from -5 to -10, your velocity has decreased. Even though you're going faster. Luke doesn't like that.
You're just going faster backwards.
Yes.
Exactly.
I don't like
But that means your acceleration is negative if you're faster backwards. Yes. If you go faster backwards, your acceleration is negative. Does that make sense?
That doesn't mean you're speeding up backwards.
Well, it means what you mean by decreasing. Is your velocity decreasing if it goes from -5 to -10? Your velocity decreased.
Technically, but
Your speed went up,
okay.
but your velocity, because velocity has a sign on it.
If you're speeding up, you can speed up in opposite direction.
Look, the speed is increasing.
You're just
But you're
going
still
velocity.
moving,
You're
right?
speeding up backwards.
It's just because it's velocity. Because it has a direction.
Wait, but you're still moving.
Whenever they oppose each other.
Now here's the, hold on to that thought. Hold on to that thought. If you're going backwards, you're backing out of your driveway, you see a car coming or whatever, you're getting ready to go forward, so you press the brake. So your velocity changes from -10 to -8 to -6 to -2. Which way is your velocity trending?
You're accelerating.
Positive.
Up.
Your velocity is increasing. You're slowing down, but your velocity has increased from -8 to -6 to -4. That means your acceleration
It's positive.
is positive.
Let's calculate
So,
Ethan, you summarized it well when you said,
They're opposite.
what's opposite?
Well, velocity and acceleration. Whenever they're opposite, they're slowing down. Whenever they're going in the same direction, they're speeding up.
Opposite what? Be a little more specific. I mean, you are right on it. When A and V have same sign. If they're both negative, then you're speeding up.
Because double negative is positive.
Kinda, because if you're speeding up in reverse, your acceleration is negative.
Yeah.
If the signs are opposite, then you're slowing down. And for some cases, if velocity is positive, that's easy. You hit the brake, you slow down. Got it. It's just if your velocity is backwards. So this is weird. Here we go. Confuse you even more. If you're backing out of the driveway, which pedal is the accelerator?
The brake pedal. Well.
Yep. Yes.
This is the dumbest thing ever. Brake.
The brake accelerates you in a positive direction.
Wait,
It depends where you're relative to.
Yeah.
Your signs are super important.
Say in the garage.
This is cool. I think we should go outside tomorrow so we can learn more about this.
Yes.
All right, so here's how you figure this out. We already have a velocity number line with velocity intervals.
Velocity and acceleration.
We said velocity was positive from 0 to 1 and 3 to infinity. We already know that. That's a different way of drawing what we already drew. Instead of just doing 1 plus and 1 minus, I put a whole bunch of pluses and minuses. Because it's going to help me in a minute.
He said we're using the space though.
The acceleration, let's see, if I want an acceleration number line, what point should be on my acceleration number line?
2.
Alright, so I need an acceleration number line. At t equals 2, the acceleration is 0, so that sets up the intervals. This is the same thing we've done before about testing intervals. If I plug in 0, I get negative. If I plug in anything more than 2, I get positive.
Wait, how do you?
Because at t equals 2, that made acceleration 0.
Okay.
So that's how I set up the interval.
So hang on.
So 1 would be a stop sign between 1
All right,
and 2.
wait, don't do the interpretation yet. Speeding up is where they have the same sign. So you have to look at both of these now and say what intervals have V and A, do V and A have the same sign?
1 to 2, 3 to infinity.
1 to 2 and 3 to infinity. And you're right, 1 to 2 you're speeding up backwards. 3 to infinity you're speeding up forwards.
So at 1, if velocity is 0, you put your car in reverse.
Oh, no, I don't want interpretations right now. Slowing down is when they are opposite signs. So that would be 0 to 1 and 2 to 3. And yes, if you want to make up some story about driving, fine, but nah. All right, we will stop there. The back is a picture. We'll do that tomorrow, but we already have that kind of blocked off, so we'll be okay.